All right, let's use energy for this guy. Okay, so for energy, we're going to, here it is rolling down this plane, right? This is 1.1 meter tall, and we know this is 3.3 meters long, right? Okay, and we've got this unique circular solid, right? Ooh, it's unique. Okay, with a moment of inertia, a highly unusual moment of inertia, right? Okay, so basically what it's got is it's got potential energy at the top, and then at the bottom here, it's got both. It is both rotating and it is also translating. So its translational kinetic energy is 1/2 mv squared, and then the rotational is 1/2 I omega squared, right? And then of course we'll substitute 2/7 mr squared for that. Omega is just v over r, and that's from the relation v is omega r. So omega is v divided by r, right? All right, so let's go. mgh is 1/2 mv squared plus 1/2 2/7 mr squared times v divided by r squared. All right, what do we got? Okay, so looks like the twos go the way of the bias in there, right? The r squared and the r squared goes away, right? And we end up with, well, 1/2 is the same as 7/14, right? Mv squared. And then here we got 1/7, which is the same as 2/14. Mv squared, is that right? Is that the common denominator? I think it is the lowest common denominator because they're both prime numbers. All right. So now we can cancel all the m's out of here, right? There we go. And then that is 9/14 v squared, right? So gh is 9/14 v squared. So v is equal to the square root of 14 ninths, not quite 2, right? Times gh. Let me just say that if it was just sliding down, it would be the square root of 2gh. Okay, but because it has to also rotate, it's going a bit slower, right? So let's plug these numbers in. Let's see. It's square root of 14 ninths times 9.81. And then what's our height? 1.1. All right, square root of 14 divided by 7 times 9.81 times 1.1. 4.645. Uh-oh. Do we find the eternal flaw? 4.6645 meters per second. All right. Let's see. What did we do? 2/7. 1/2 I omega squared. Pretty sure that's 1/2 plus 1/7. Is that right? Is that right? I think it is. Yeah, let's just double check this. I'm just double checking. It's possible that answer is wrong, you know. Maybe nobody ever did problem 4. There's a good chance, right? Okay, so let's see. Okay, so 1/2, and then that's definitely 1/7, right? And 1/2 plus 1/7 is the same as 7/14, because that's 1/2, right? Plus 2/14 is definitely 9/14. All right. Oh, okay. I definitely typed this into my calculator wrong. Okay, here we go. I've got it. I'm back. All right, let's go back in there. There it is. Okay, I got it. When I type the actual numbers that I have here, I get 4.097 meters per second. which would be about 4.10. All right. It's like I thought we'd found the eternal flaw in this thing. Okay, what I did was I typed a 7 there. I don't know why. And then we want to find the acceleration. So v squared is u squared plus 2as. And we'll use the length of the plane here, right? So 4.097 squared equals 0 squared plus 2 times the acceleration times 3.3, right? Okay, so I'm going to square the number I've got there. Divide by 2, divide by 3.3. And I get 2.543 bar meters per second squared. Very cool.